Welcome to the video lecture series of Theory of Computation. Today we are going to learn about the CFG conversion. So in this video we are talking about the conversion from the regular expression and context-free language to context-free grammar. I am your instructor Poonam Patel. Let's start to understand this concept. So this concept, we can understand this concept by using the example. So example number 1, the statement is given like this. We need to construct a CFG for the language which having a 0 or more number of A. So this is a regular English. So and sigma is containing a single A. So for this kind of statement like this, they have given 0 or more number of A. So we know that for this, how we can write down the regular expressions. So they said that they said that the language containing a set of string which containing a 0 or more number of A's, where our input alphabet containing only single A. So in our string is symbol is containing a single A. Now, when you are going to converting into a context-free grammar this statement, so whenever you are going to convert the either regular expressions or the language is given into a context-free grammar, so what you need to do? So first of all, you need to understand what kind of set of string is containing this language or regular expressions. So after analyzing this, you can convert this set of string into a grammar, because grammar is generally used to generate the set of strings. So for converting this, how we can convert this given language into a context-free grammar. So what set of string is generated? Start with the minimum length. So 0, it means that the set of string is containing an empty string. It means that it does not contain any A raised to 0. Single A, double A, triple A, 4A, and it is infinite, okay, like this. Now it is an infinite set of strings, this language containing. So as we know, what is the regular expression for this? So we can write down this is A star. So here I have write down the solution for this. First of all, A star. Now if you see, the set of string A is repeated 0 or more times. So when the symbol is repeated, so for this symbol, how we can convert this context-free grammar? Understand this concept always. Understand this. So in a grammar, as we know, the production words containing context-free grammar, left hand side symbol is always containing single non-terminals, and right hand side containing a terminal non-terminal combinations. So here I have write down like this as derives. Now as in our grammar, here I have used as a start symbol. So when I am going to generate the set of strings, it always starts from this capital S. Now this grammar is generated 0 or more numbers. So term is repeated A. So whenever the term is repeated, I have write down this single A, because A is repeated. So write down the symbol which is repeated in this dot. Now for the repetition in the grammar, how we can write down? So the symbol which you have write down, the left hand side of this arrow, which is our non-terminal, you have to write them over here. So this production is simply repeated this A dot as term. Or the next is S derives. Now always remember, when a star is given, so this is repeated, but you have to write down over here the minimum length of string. Our language is containing minimum length, it is a null, so you can see over in null. So here we have to write down for this repetition term which containing the minimum length, we have to write down S derives null. So he can also write down like this A, S, and null. Let me check whether this grammar is generated this set of string or not. So here you can see S is replaced by first null. So the first is generated, null string, empty string. Now single A I want to generate. So S is replaced by A. S is replaced by A. S. Single is generated. S is replaced by null. So A dot null means it generates the single A. Always null symbol in the input string we can ignore always. But if input symbol is containing only null, we need to consider it as an empty string. Always remember this. So what this grammar is generated? A dot null, it means that it generates the A. Now I want to generate the double A. Now I want to generate the double A. So S production is replaced by AS. Now this term is always helping to generate the number of A's. Again S is replaced by AS. So this is my double A. Now the stopping state is as data is null. I have to stop over here because I want to generate the double A. So I hope this example is clear to you. Now move on to the next example. Example number 2. Now they have given the regular expression directly and we need to convert it contextual grammar. Now the term is given like 0 plus 1 star. So always remember 0 plus 1 in a regular expressions, plus meaning that plus is means either or. Either you can take 0 or you can take 1. And star is meaning that this term is repeated 0 or more times. So what kind of set of string this regular expression can contain? So for star, so it means that it always containing a null string because star is repeated 0 or more times. Now in place of star, if I put 1, so what kind of symbol it generates? List to 1, it means that its term is repeated 1 time. So either you can pick the 0, it means that containing 1, 0 or 1. 0 or 1. If star is repeated 2 times, so always remember this is a universal which contains any number of 0 and 1's combination. If it is repeated 2 times, so 0 0 you can generate, 0 1 1 0 this combination is generated because its length is 2, so always containing a 2 length symbols. Then again star is repeated 3 times, 4 times. On this way we can generate the set of strings 0 1 0 0. So when you are going to convert the regular expression, you need to understand what kind of set of string is containing like this. Okay. Now, if you see in the previous video we have seen the term is repeated, but here 2 terms is repeated and these 2 terms are connected with the or. So how we can generate the grammar? So it is a very simple for this. As now this 2 terms 0 1 is repeated. Now any order is given, either 1 appears before 0 or 0 appears before 1. No, there is no any order, but it is fixed 0 or 1 is repeated. So for the repetition I can write down 0 is repeated, so I can write down like this. So this term is given to me 0 star, 0 is repeated any number of times. You can use this production for repeating the 0. Or 1 is repeated, so 1s. So this term is repeated 1 star, like 1s. Now what is the stopping criteria for this? So you have to write down the null. S. So this production is help me to stop and generate the set of strings. So why I have taken over here? Because the set of string which is containing in this language, in this regular expression, it is a null. So let me check. S derives null, yes. S derives single 0, yes. It is also derives 0 as, and s is replaced by null. Okay. So 0 dot null, it is 0. 1, yes, s is replaced by 1 as, and it is replaced by null string like this. Can we generate 1 0? Yes, you can generate. S is replaced by 1 s, and this s is replaced by 0 s. I can use the production of this grammar, okay, for generating the set of strings. So 1 always for reading the string left to right, okay, and terminals we need to always read the terminals. leaf nodes, we can say that 1.0 and s is replaced by null, so 1.0. So here you can see over here I have written down the expression like this. Now move on to next. Next example, A star B. Now here I have taken two letters A star dot B. Now B is a single type. Okay, always remember. So what type of string is containing over here? So before converting into a context-free grammar, you have to know about what kind of string is generated. So A star B. So for this type of regular expression, what we have to do? So the repeated term, what we can do? Always repeated term always assign for this kind of combination. We can assign this repeated term to the another non-terminal we can use. Here I have used the non-terminal symbol A. A is helping to generate A star. Now A is not repeated, so that's why I cannot use another non-terminal for this non-repeating symbol. So if I check what kind of set of string is generated, so in place of star, if I put 0, so it means that null dot b, so minimum length is b. So what is the string? B. Then A star, so AB, double A. What set of string is regular expression? So if you see, A is repeated, B is not repeated but A is repeated, but every time B is always concatenated with a number of A's and it is appear at the end. Always remember this. Okay. So for this kind of regular expressions, always what we are going to do, we have to assign the non-terminal symbol for the repeating term. So I have to write down for the start symbol as derived. Always remember this is the first production. Start symbol dot B. Okay, A dot B. Now A is helping to generate A star. So we have already discussed in a previous in our first example A star how we can write down the left hand side non-terminal for the repeating we have to write down over here like this. It means that this term is generating number of A's and A star means the minimum length for the star is null string is generated, so it is null. Always remember for this term, what is the minimum length? It is null. Okay, so here you can see the solution for this. S derives A dot B and A derives small a capital A and A derives null. Now next is, so only difference in this example is I have included the third term which is a A star. So how we can write down the regular expression for it? It is a very simple. The term which is repeated we have to assign the new non-terminals. So here I have used A. The term which is not repeated we have to not replace it with the non-terminal symbol. And if you see this term is same as this term. So there is no need to take another non-terminals, only write down the A. So write down the regular expressions as A. Here I have not described what kind of set of string is generated because in the previous example we have already discussed what kind of set of strings. So for this you can also write down the set of string and then write down the context-free grammar directly. Okay, and you can also write down the context-free grammar if you know. You can directly write down the context-free grammar. Okay. So A B dot B. So A dot this three term is connected with the concatenation symbol A B A. Now A is helping to generate the number of A. Simple. This is and now this is the answer for this example. This is the example. So here you can see the solution. Okay. Now move on the next. So I hope this concept is clear to you. Now let me solve this example. So here there are two terms which is repeated A star, A plus B star. So as we already discussed, whenever the term is repeated in the given regular expression, what we are going to do? We have to assign the non-terminals. So here there are two terms which is different. So that's why I have used two non-terminals. If the term is not repeated, we have to write down as it is, like with the concatenation. A, this term is A, now next is B, and this term is capital B. Now this capital A is A plus B star. So as we already know how we can write down, and star means null, and B, which is a B derives A, B and null. So here I have write down the regular expression as derives A dot B dot capital B. A derives small a capital A or B small b capital A or null, whereas B is given to a number of A's. So B derives small a capital B or B derives null productions. So in this way we can write down the context-free grammar for this given regular expressions. Now here given the context-free language. Here they have given the language. So how we can write down the context-free grammar? So as we discussed, when you are going to write down the context-free grammar, first of all you need to understand what kind of set of string it containing, starting with the minimum length always. So here here in this example, the power is given n greater than equal to 1. So first of all you need to understand the language. A raised to n, B raised to n. So they say that in this language A raised to n, B raised to n. So if you see, both A and B's power are same. It means that the number of A should be equivalent to the number of B. And n power is started from the 1. So what kind of string is generated? Suppose I have taken the n power is 1. So AB, n power is 2. So double A, double B containing. N power is 3, triple A, triple B. So if you see in this language, the term is repeated, but number of term. The first thing is term is repeated. The second thing is order is given. Order is fixed. The number of A should be followed by number of B. So first A appear, then B's appear or B's appear, and the next is both A and B's powers are equal. So how we can generate for this kind? So same as derives. Now understand this. A, small a, because it is repeated. In middle, I have write down the same symbol which I have write down over here, this left. And next is after A, which term is repeated? So A as B. So this production said that whenever the number of A is repeated, with the A, number of B is also repeated. And first A's appear and then B's appear. And the minimum length is AB for this, so that's why we have to write down. Now let me check. As single AB generated, yes. Double AB generated. So for the double AB, this as ASB is replaced by this term is repeated. Double AB. So ASB, sorry, ASC is replaced by AB. So double A, double B. 3A, S is replaced by A as B. S is replaced by A as B, and I want to generate and last S is replaced by B. So in this way, we can generate this. Now, suppose nth power is started from the 0. So like this, n greater than equal to 0. So what modification we can do in this grammar? So only modification we have to do is the minimum length it generates, it is a null. So in place of this, we have to write down the null. So our grammar is like this. Okay, for n greater than equal to 0. Okay, because minimum length it containing a null strings. Now the example a raised to I, b raised to j, c raised to k, where I equal to j or c equal the next is j equal to k. So in this language, they have given the two conditions, and these two conditions are connected with the OR. So how I can convert this language into context-free grammar? So what we have to do, I have to write down two grammars, two different grammars, and connected with this two grammars with this OR condition. How I can do? So here I have taken this condition, and they said the first condition is said that the power of I is equivalent to the power of j. So can we write this language again? I equal to j. So in place of j, I can write down. Okay. So I have underlined the symbol which containing an equivalent power, and this. Why I have to do this? Like, because, so if you remember in a previous slides, we have to write down the context-free grammars when the power of A equivalent to the power of B. So I know the logic for this. So same logic I can apply over here. So I can replace this with this non-terminal symbol A, which gives the equal number of A and B, and C raised to K, which is not dependent on any another term. So it is replaced by the B. Now, what is the starting value of ijk? So when the starting value is not given, we have to assume that I is greater than equal to 0, j is greater than equal to 0, and k is greater than equal to 0. So here we can write down like this: AB, A is number of A. So same concept we can use. So A and B both are repeated equal number of times, and the minimum length of I is null. Sorry. This is my A, and B is helping to generate C raised to K, where K is starting from greater than equal to 0. So if K value 0, K value 1, K value 2, for this C is repeated. So C raised to 0 null, C raised to 1 single C, C raised to 2 double C, 3C, 4C, like this. So it is like C star. So same concept I can use: small c, capital B, and null. This is my first grammar. Same way I can use the conditions like this: j equal to. So here I raised to k, b raised to j, c raised to j. Same concept I can use. For the different power, I have write down this d and e, de for d, which is generated a star, and e, which is generated equal number of b and c. Sorry, this is small c. And now these two conditions are associated with the OR. So I have write down this is S1 and S2, and last at the end I have write down this two condition S1 or this symbol. This symbol is indicating either you can use this production or this production. So in this way we can write down the context-free grammar. So I hope this concept is clear to you. Thank you all.